chapter 4.5, which is solving quadratic inequalities. Solving quadratic inequalities. So, two-step process. First, remember that, recall that f of x greater than 0 refers to intervals of x above the x-axis. F of x less than 0 refers to intervals of x below the x-axis. So the process then is to sketch a quick graph of the functions. X-intercepts are essential. X-intercepts are essential. So let's look at a few examples. Suppose I have to determine the solution, solve x squared plus 11x plus 30 is less than 0. So to solve, first we see that the a value is positive, a is greater than 0, so the graph is turned upwards. We set this equation equal to 0 and factor it to find the x-intercepts. Okay, so this factors as x plus 5, x plus 6 equal to 0. Meaning that we have an x-intercept at x is equal to -5 and -6. So if we were to sketch a real quick graph of this, this graph would be, this is all we need here, by the way. Okay, this is y and this is x, and we have -6 and -5. And we know the graph is turned upwards. We know the graph looks like this. At this point, knowing the h and k value does not affect the solution to this inequality. Okay? Knowing the h and k value does not affect the solution here. So we've got our little sketch and we look at what the question is asking. The question is asking for values less than 0, where the y values are negative. In other words, it's asking about this portion of the graph. the interval between -6 and -5. So solution from -6 to -5. Okay, this is f of x. Let's write that back. This part of the graph is f of x less than 0. In other words, y is negative. Now, let's say that this question was worded differently and we were asked to solve x squared plus 11x plus 30 greater than or equal to 0. Then they would be talking about the portions of the graph that are above the x-axis. These two pieces, that those portions have y values that are positive. So f of x is greater than 0 for those. And this greater than or equal to says we're including -6 and -5. So from -infinity up to -6 would be a solution. Bracket on the -6. And then from -5 to positive infinity, because remember this graph opens up forever. So from -5 to positive infinity would also be a solution to this problem if we were asked to solve greater than or equal to. So keep that in mind and how that affects how greater than or less than affect the graphs. Okay. Let's look at a few more problems. Solve question 2. Solve x squared plus x is greater than or equal to 2. So we would write this as x squared plus x minus 2 is greater than or equal to 0. Factor it. Now we know the graph is turned up because a is equal to 1. And if we factor this, two numbers that multiply to give -2 add to give +1. Okay, so x could be equal to -2 or +1. So if we were to sketch this graph, between -2 and +1 turned upwards, okay, turned upwards. And again, it's asking about the x values for the portion of the graph that are below the x-axis. So simply the interval from -2 to 1, and it's greater than or equal to, so this time we will use brackets. X squared minus 9x is greater than 0. So factor out x, we have x minus 9 is equal to 0. So the x-intercepts are at 0 and +9. Okay, so we would write those intercepts in at 0 and 9. We know the graph is turned up because the coefficient of x squared is positive. 0 and 9. Sketch a quick graph here. I hope you guys can see that knowing where the vertexes does not affect the solution for this type of problem. And this is asking about greater than, so it's asking about the portions of the graph that are above the x-axis, from negative infinity up to 0 and from 9 to positive infinity. In other words, it's asking about these two parts of the graph. So solution from negative infinity to 0, and then from 9 to positive infinity. Put that union in between. Sometimes you're given a graph and you're asked to solve a problem. So here let me copy and paste the graph here. This question is two parts. Part A is asking about f of x is greater than 0. So again, it's asking about the part that is above the x-axis from negative infinity to negative 9. So solution, negative infinity to negative 9 is greater than, not greater than, or equal to, so parenthesis, and then from 3 to infinity. And then part B is asking about f of x less than or equal to 0. So it's talking about this portion of the graph, or the interval between negative 9 and positive 3. This time in brackets because the inequality has an equal sign with it. X squared minus 25 is less than 0. So this is a difference of squares, which is x plus 5, x minus 5 is equal to 0. So the intercepts are at positive and negative 5, and the graph is turned up. So negative 5, positive 5, graph turned this way. Above the x-axis then would be below the x-axis would be that portion between negative 5 to positive 5. So solution is from negative 5 to positive 5. Six, x squared minus 3x plus 9 is less than or equal to 0. So this is one of those graphs where you want to look carefully at the equation. We know it's turned upwards, and notice that we cannot factor this. Cannot factor. And then if we try to use the quadratic formula to find the x-intercepts, we would have minus b plus or minus b squared minus 4 times 1 times 9 over 2 times 1, which is 3, plus or minus 36 minus 9, which is the square root of negative 27 over 2. Now, we know that we cannot find the square root of a negative number, so this has no solution. In other words, this graph does not have an x-intercept, so no x-intercepts. And if you wanted some confirmation, let me just open up my calculator and show you exactly what's happening with this graph, okay? Because if it has no x-intercept and it's turned upwards, it could only mean that the graph is located above the x-axis. Okay, so y equals 2, and I put in that graph, I have x squared. Uh-oh, forgot to clear this. X squared. I don't know what's wrong with this thing right now. X squared minus 3x plus 9. And I'm going to do this in their standard window, zoom standard. So for some reason I can't see the graph. Let's go back to what I typed in here. Hold on a second. This thing's frozen. My calculator is frozen. Give me 1 second. Okay, I got my calculator to work. So here's my graph. Notice the graph is located above the x-axis. Now, I wanted to tell you what this means to us. So we're going to copy this and put it over, okay? This means that there's no intervals where y is negative. So this problem has solution, no real solution. Now, if it were asking about solutions to problems, say it wanted FYI, if it were asking about, say, x squared minus 3x plus 9 is greater than 0, it will be every single x value on the number line, because this graph opens forever in both directions. So in this case, the solution would be all real numbers from negative to positive infinity. Okay? For y positive. And this is an FYI only. All right, 2 more quick examples. Number 7, 3x squared plus 16 is less than or 8x. So 3x squared minus 8x plus 16 is less than 0. And if we try to factor this, we're not going to be able to factor it. So again, we want to put a graph like this into the calculator and see what happens to it. First thing is to get that graph into the calculator and see what happens to it. So that's 3x squared minus 8x plus 16. And if we graphed it, we see this. Well, we don't see anything. The calculator is doing strange things again. I'm back. Okay, I got my calculator working again. So if I typed in my function, the reason we can't see this graph is because the vertex is somewhere at the top. So you wanted to zoom out, number 3, and press the enter button. And now you can see this graph is also located above the x-axis. Okay, so second, again, the solution would be no real, it could be called an empty set or no real solutions. Since it's asking about the portion of the graph that's above, below the x-axis. So solution, and there's two ways you can express this. You can say no solution, no real solution, or you can say empty set. Okay, and since graph does not exist for negative y values. For negative y values, the graph does not exist. Okay. All right, one final example, and then we'll end this. This question 8. Negative x squared minus 4x plus 12 is less than or equal to 0. So this graph is turned downwards, okay? Because a is less than 0. So to factor this, the first thing you want to do is change all the signs. X squared plus 4x minus 12 is equal to 0. Factor it. So this is x plus 6, x minus 2 is equal to 0. So the x-intercepts are at negative 6 and positive 2. Sketch a quick graph, negative 6 and positive 2. Graph is now turned this way, downwards, okay? Graph is turned downwards. And they're asking about less than or equal to 0. So they're asking about these parts of the graph here that are highlighted, from negative infinity to negative 6 and from 2 to positive infinity. Negative infinity to negative 6, it's less than or equal to, and then from 2 to positive infinity. Okay. Okay, let's go ahead and end this.